geobyte.
Dear students, now let us discuss the previous year questions for the very simple unit, that is units and dimensions. Okay, from this very simple unit, you can expect one question for the BITSAT exam. BITSAT exam. That is the weightage of this particular small unit, and it is very easy also. I hope all of you clearly understood all the theory concepts what we discussed for units and dimensions. Understood or not? Yes. Then let us take the very first question. Look at the very first question asking like this. The dimensional formula of latent heat is, you know, the heat transfer, heat transfer is a kind of energy. Heat transfer Q equal to mass into latent heat. Okay, from this latent heat, L equal to heat transfer, or I can say heat energy. Heat transfer can also be called as heat energy divided by mass. As we all know, energy unit is, listen carefully, energy unit is joule. Joule means Newton meter. Newton meter. Then, as you know, Newton is the unit of force. Newton is the unit of force, and meter is the unit of distance. As you know, force F equal to MA, M, right? M into A, acceleration L by T power 2. It is equal to M L T power minus 2 is the dimensional formula for force. But energy equal to what? Product of force and distance. Energy energy equal to product of force and distance. L. Here distance, let it be, here you may be confusing with L because L we are using for latent heat. Distance. Okay. The dimensional formula for force is M L T power minus 2 distance into L. Right? It is equal to M L square T power minus 2. That is the dimensional formula for energy. Remember that one. So heat energy dimensional formula M L power 2 T power minus 2 divided by M. M. Right? Now this M is getting cancelled. M is cancelled. Finally it is M power 0 L power 2 T power minus 2 is the dimensional formula for the latent heat. M M power 0, look at the option C, M power 0, L power 2, T power minus 2. Option C is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem asking like this. The dimensions of coefficient of self-inductance are, as you know, energy stored, again energy stored in inductor, energy stored in inductor U equal to half L into I square. Here L is coefficient of self-inductance, where L equal to coefficient of self-inductance. Let me write it clearly. Coefficient of self-inductance. Okay. From that, right, I can write coefficient of self-inductance L equal to 2U by I square. Here I is the current, which is in amperes. Right? I equal to current. Let me write here. I equal to current amperes. Okay. Then you know energy dimensional formula. Here U is the this is the U energy. Just now we have decided energy dimensional formula m L power 2 T power minus 2 is the energy dimensional formula divided by I amps A power. Now you simplify it. It is equal to m L power 2 T power minus 2 A power minus 2. That is the dimensional formula for the coefficient of self-inductance. Look at the option A, m L power 2 T power minus 2 A power minus 2. Option A is absolutely correct. Understood clearly? Yes. Then look at the another important problem asking like this. On a temperature scale x, the name of the temperature scale is given x. The boiling point of water is 65 degree x and the freezing point of freezing point of water is minus 15 degree x. Assume that the x scale is linear. The x scale is linear. That means temperature is linearly varying with the thermal property or thermodynamic property. Okay, understood? Like how the you take the mercury thermometer. In a mercury thermometer, the once you touch the thermometer sensor to the hot body, the mercury present in the thermometer is linearly expanding. Therefore temperature is directly proportional to expansion length. That is called thermometric property. It is given that the x is a linear scale, then the equivalent temperature corresponding to minus 95 degree centigrade 95 degree x on the foreign heat scale would be. Okay, for that the relation between the different temperature scales is x minus lower fixed temperature in that scale x scale divided by upper fixed temperature minus lower fixed temperature equal to thermometer reading in degree Fahrenheit, because it is asking what is the equivalent temperature in Fahrenheit scale corresponding to minus 95 degrees centigrade minus lower fixed temperature in Fahrenheit scale divided by upper fixed temperature minus lower fixed temperature. Okay, as you know, for Fahrenheit scale, lower fixed temperature is 32 degree Fahrenheit, upper fixed temperature is 212 degree Fahrenheit. Here lower fixed point means freezing point and upper fixed temperature means boiling point. Okay, let us take those values. Here asked you to decide what is the Fahrenheit temperature corresponding to minus 95 degree x. Therefore, minus 95 divided by lower fixed point is given, that is freezing point, minus minus of minus 15 divided by upper fixed temperature in x scale is 65 minus of minus 15 is equal to thermometer reading in degree Fahrenheit minus lower fixed temperature for Fahrenheit scale is 32 divided by upper fixed temperature 212 minus 32. Now minus 95 minus of minus 15, that is minus 80 divided by 65 plus 18 plus 80 equal to thermometer reading in degree Fahrenheit minus 32 divided by 212 minus 32. It is 180. 180. So here it is minus 1 equal to thermometer reading in degree Fahrenheit minus 32 divided by 180. From this thermometer reading in degree Fahrenheit minus 32 equal to minus 180. Thermometer reading in degree Fahrenheit equal to minus 180 plus 32. This minus 32 becomes plus 32 if it is going to other side. that is becoming minus 148 degree Fahrenheit. Minus 148. Look at the option D. Option D is absolutely correct. Understood clearly? I try to explain the each and every point at your understanding level. Okay?
Geobyte.